Welcome to the Doherty Water for Food podcast. Since 2010, the Doherty Water for Food Global Institute at the University of Nebraska has worked toward one goal, a food and water secure world. One in which global food security is ensured without compromising the use of water to meet other essential human and environmental needs. It's a daunting vision, but one that is vitally important. This podcast amplifies the voices of those making waves in this space. We hope you enjoy today's episode. Today I'm speaking with Babak Safa, a postdoctoral researcher at the Doherty Water for Food Global Institute. Babak has been with the Institute now for 5 years, and he specializes in agricultural meteorology, micrometeorology, and vegetation-atmosphere interaction. Before coming to the Institute, Safa was a volunteer researcher for Project Drawdown in Sausalito, California, and he's also a certified meteorologist in his native country of Iran. He holds both a doctorate and a master's degree in agricultural meteorology, as well as a bachelor's degree in agronomy and plant breeding. So, Babak, it sounds like you've done quite a lot of interesting work in your career. So, start by telling us a little bit more about yourself and why you decided to get into this line of research, especially in Nebraska.
Okay. First of all, originally I came from Iran, and before coming to United States, my background, as you mentioned, was in bachelor agronomy and plant breeding, and then with my master in the University of Tehran, I joined to the Iranian Meteorological Organization. And right before that, I participated in WMO, World Meteorological Organization. I got meteorologists certified with the WMO. Also, after the finishing my master, I joined for almost a year and a half to drought mitigation and adaptations center in the Iranian Agricultural Ministry. And finally, I came to United States and I started my PhD. First of all, for a while I was in Iowa State University, and then came to Nebraska because Nebraska and University of Nebraska in Lincoln has a very powerful section, and also the scientists work in micrometeorology and ag meteorology. I was really enthusiastic to join to this university and agronomy and the School of Natural Resources department to continue my education.
Well, from what I understand, the people who are in the office with you tell me that you're kind of a constant source of helpful weather updates. Mm-hmm. And in your career, you've been especially interested in agricultural meteorology. So what is that exactly, and why is it important to you for your work at the Institute?
Just you talk about the agricultural meteorology, and especially in this area, I want to tell you something, because when you are forecast the weather, several groups using that forecast. For example, some of those is working in the aviation centers like airports to track the forecasting, to control the airways and flights. Main group using the forecasting the weather is the growers and farmers. That means return to agriculture. Everybody knows the effect of weather on agriculture is really important in all parts of the world. I'm tracking and bring the forecasting and knowledge of meteorology to agriculture. I think this is important also for Water for Food, Doherty Water for Food Global Institute, because this institute is working in water and, from the other hand, food, how much water effect and effect on the food production. One of the main factors effect on the water storage and the water accessible for the agriculture is the weather. That was my background relation to the institute, and I can and I would be useful for institute over the last 5 years to work in this area.
And you also do a lot of work with remote sensing and eddy covariance flux towers. I have never heard of that. Obviously, it's very technical. So, can you break that down for us, how it works and its benefits to both agriculture and food production as a whole?
Eddy covariance tower, or is better to say eddy covariance system, are very high-tech systems to measure, to help us to measure all greenhouse trace gases, or it's better to say the emission of trace gases emitted from any type of surface. This is, I think, really important for climate change. Scientists and everybody work in this area, global warming and climate change, because the measuring some greenhouse trace gases like carbon dioxide, water vapor, nitrous oxide, methane, all of those has a big impact to the global warming and increasing all of those gases in the atmosphere over the last century, just with using the different sources, and one of the main is the fossil fuel, start to increasing over the last century, all of those gases in the atmosphere. You can see the amount of increasing over the last decades also is really high. And these two, that means eddy covariance system, bring this opportunity for us to measuring the amount of those trace gases emitted from a different surface, like agricultural land or any type of ecosystem, also urban area, and any other surfaces. You know, when we have access to accurate data about all of those gases, this is really helpful for scientists to run different scenarios, near future and far future, and forecasting the temperature and rainfall. And as you know, the increasing the temperature from the one hand is one of the main parameters known for climate change and has a big impact for future life. And also changing the frequency of the rainfall also happened over the last decades based on the increasing the amount of greenhouse gases in the atmosphere, makes severe problem for most of the people around the world, and has a main impact on the life for different countries.
So what are the current projects that you're working on?
At present, I'm working with different projects in the Institute. One of the main one is related directly to measuring the eddy covariance system, the measuring the gas fluxes with eddy covariance system. I joined as a co-PI to one project just funded with Department of Energy as a smart farm project. In this project, we're supposed to install the eddy covariance system in different fields over the different region. The first phase is installed in Nebraska to measure in the cornfield to measuring the amount of the emission of greenhouse trace gases. We measure carbon dioxide, water vapor, methane, and nitrous oxide. Also, supposed to install another one in Iowa with collaboration with the USDARs at that location. The same in Morris, Minnesota. This is one of the major projects I'm working on that. One project, the PI in the University of Hawaii, and we are working as a collaborator in Nebraska, forecasting the ET, evapotranspiration, and rainfall over the whole states. And this project help us to forecast ahead of evapotranspiration and rainfall. This is really important for farmers and growers, because when we know how much evapotranspiration happens, that means how much water release from the agricultural lands and how much rainfall is coming, and subtract those values. Another project just recently and this year I'm starting work on that is the project we are collaboration, the Institute collaboration with the NRD, Natural Resource Department. And we are installing different, again, towers, ecovariance tower, in different ecosystem like natural grassland in the west of Nebraska and cropland, again, in the middle part and the west part of Nebraska, to measuring the amount of ET over different canopies and ecosystem. This is important first to, again, help to farmers to managing the irrigation scheduling. And the other hand, is important to know it's better for example, for the productivity of the land, it's better to save the grassland or no, it's better to change those grassland and natural land to cropland like maize field and soybean field. Also, I think this is really important to know not only the NRD, the Department of Natural Resource of Nebraska, also for growers and farmers to know which side is better and which productivity is higher and help to also the ecosystem in the west of Nebraska.
So I see that your latest publication looked at accurate ways to measure net ecosystem exchange. So what is net ecosystem exchange and what did you find out in your research?
Net ecosystem exchange is the net carbon dioxide emission, is better to say. I worked over my PhD and over my thesis in the University of Nebraska Research Center at Mead, and working with the ecovariance tower installed in 3 sites. The first site was the irrigated maize, second one irrigated soybean rotation, and the third one is rain feed. And I got very good results and finally can also simulate the amount of net ecosystem exchange over the maize irrigated and rain feed, and compare what is the versus between the rain feed and irrigated and how much is different between the carbon sequestrated between these 2 sites. That was really, really nice research for me, and I got also I published in the very nice journal.
Well, what does this mean when we look at future strategies for combating climate change?
This is really good question because when I explained in the last question what is the net ecosystem exchange, and net ecosystem is better to say carbon dioxide exchange. It's really helpful for climate scientists to understand how much carbon release over the time from different area on the earth, to put those data to climate change models and run the models and see what's happened for near future and far future, forecasting the temperature and precipitation and the other meteorological parameters. And also collecting much more accurate data now help to us and to put the different models and again run the models, climate change scenario models. And this is, I think, really important for not only for climate change scientists, for the policymakers and for the governments around the world to make a very good decision about the future.
Well, expanding on that a little bit, how do you see, looking down the road, how do you see policymakers and land managers actually using your research and your findings, both short-term and long-term?
The amount of the greenhouse trace gases emission is really important for not only for the scientists, for the policymakers, because I mentioned it has a big impact for the future of life on the earth, based on the increasing the temperature and changing the frequency and fluctuation of the rainfall in different parts of the world. part of my research, last research was also yield forecasting, crop yield forecasting and prediction. And I predict with the artificial intelligence the amount of the wheat yield when I was in my country. And also that research also was really helpful for the farmers. And I bring those models also to United States and run those models here, again for different crops like maize here. And that was really helpful because when you know a few weeks to few months before harvesting, how much is the crop productivity and crop production, it's really important for not only for organizing and management the marketing, it's also really important for government to how much export and import for different countries. Also, I would like add another things, especially for Nebraska. This is really also related to Dorothy Waterford Food Global Institute, because I try to just forecasting each phenological stages over the growing season for each crop. And that was really helpful for farmers to know which stages is coming, for example, over the next few days, over the next few weeks. You know, some stages of crop is really sensitive to amount of water availability. And if we know, for example, for those stages, when it's happened, for example, next few days or next a few weeks, and we can forecast how much rainfall is coming, especially for rain-fed area. It's important to managing the water availability and at least one-time irrigation on the field before those sensitive stages happen, and increasing the amount of the fertility and also the amount of production at the end of the stages and growing season. The other side, and also the other important one, is the leaching of nitrates in the groundwater as well. And also this research to controlling and forecasting the each phenological stages in cropland help to bring the best irrigation scheduling for the farmers. And finally, the farmers can use the optimized water put on the field. And this is also really important to not overusing the water for the field over the growing season, because overusing the water also increasing the amount of leaching the nitrate in the surface and from the surface to ground water. And this is not good for, especially in Nebraska.
As we said, you were a volunteer researcher for Project Drawdown in California. It was called the most comprehensive plan ever proposed to reverse global warming. Tell us about that experience and about the solution that you spent time researching.
Project Drawdown established in 2014. The idea behind that was reducing the acceleration of the greenhouse gas emission on different parts of the earth. And that was really helpful to increasing the global warming impacts for the future. His team organized 100 subjects from different category, solution and different, it's better to say assumptions, to has an impact on the global warming and climate change. One of those was agroforestry. And I work with that research group work in agroforestry. And that was really a privilege for me.
Well, what would you say really has been your most interesting finding or part of your research? You've had a lot to choose from there.
Whenever, for example, after my high school or during the high school and after that, That was one of my big challenges for me is the biosphere-atmosphere interactions. That means how much these two has interact to each other and really what is the relation between tools. From one hand, biosphere, from the other hand, atmosphere. Over my bachelor and master, and especially over my education, academic education after high school, and I would like and try to forecasting and simulation the impact of weather to crop over my past experience and research. One of those was the crop yield or crop production. The other one was the greenhouse gas emission. One of the best tools to help me to get those forecasting and prediction and help to get the accurate, increasing the accuracy and precision of all of those forecasting was artificial intelligence or AI. Over the last 15 years, I used the AI as one of the powerful tools for forecasting and prediction. And that was one of the also my big output of my researches over the last decade as well.
Well, what do you say is the biggest challenge in your work and how you approach the challenge?
One of the big challenges for me anytime is the forecasting. Forecasting and prediction of any meteorological or micrometeorological parameters. All of those meteorological phenomena, those are the major force parameters and input parameters for different climate change scenarios. On the other hand, using the artificial intelligence, especially artificial neural network or any type of fuzzy logic algorithms also helped me to get much more accurate and precision of those forecasting.
Well, let's talk about working for the Water for Food Global Institute. How has working for the Doherty Water for Food Global Institute helped you with your research? And what role has the Institute played?
Water for Food Global Institutes bring this opportunity for me to be involved to different projects as a co-PI, some of those as a staff. And that was really good experience for me to work with those projects and learn a lot about different subjectives, different research area, and also bring this opportunity for me to continue to work after finish my PhD, to work still in eddy covariance systems, to collect the data, gather the data for different type of data for gas emissions, and working with those data, analyzing those data to find the best relation between the biosphere, atmosphere, and edaphic parameters to each other. Also understanding how much climate can affect and has an impact on agriculture and water, and generally what is the interaction or relationship between the water, agriculture, and climate, all three together. Those subjects and these part of the research and the work is not only help me and help the institute to improving the institute's aims as well. Also is important for increasing the productivity and optimize the water use and other input supply and farm services. And also is important, all of those for growers and farmers, especially in Nebraska.
Well, Babak, that's all the questions I have. Is there anything else you'd like to add?
Oh, thank you so much. Thank you so much. I really appreciate it for the Doherty Water for Food to bring this opportunity for me and organizing this podcast. And I really appreciate it.
Thanks for joining us this time on the Doherty Water for Food podcast. Make sure to visit our website, waterforfood.nebraska.edu, to view show notes or subscribe so you don't miss future episodes.